Currently, the incorporation of nanodevices into packaging seeks to improve their function using nanomaterial as packaging or coating material about the food, frozen about temperature, among others. The use of nanotechnology will allow food to stay fresh for longer thanks to lighter and more flexible packaging material with ingredients resistant to heat, like mechanical or other demands, and material capable of absorbing oxygen and moisture. Furthermore, nanoparticles with antimicrobial properties and the repellent surface are expected to be widely applied to packaging material and machines used to produce food.
Nanotechnology starts playing its major roles of fabrication, characterization, and manipulation of nanorange molecules, and pursued its future discoveries in biology as nanobiotechnology, especially in biopolymers involving the design, manufacturing, processing, and application of polymer materials filled with nanoparticles and nanodevices. The effect of non-degradable plastics changes the soil nature and accumulation of toxic gases in the atmosphere leads to global warming. Hence, biodegradable plastics come into effect but they lack mechanical strength and permeable to water and gases.
The food industry. The food industry is constantly looking for new technologies to further improve critical parameters, such as the quality, safety, traceability, and shelf life of food, as well as to assess as there may be a migration contamination. In other matters, polypropylene is the most widely used thermoplastic due to its easy combination of processability. Its mechanical properties allow coats, however. Some of its limitations are the oxygen barrier preventing use in the packaging industry, but nanotechnology has been able to overcome by polymeric compounds, nanoclay, which show an improved oxygen barrier and thermal properties, making T. Monomerylene-based organoclay demonstrate a high capacity to improve the vapor barrier properties of oxygen and water in polypropylene because clay imposes a restriction on gas diffusion. Environmental factors lead to alteration of sensory characteristics, loss of quality, production of harmful chemicals, and growth of food-borne pathogens capable of causing serious diseases. Food packaging can be improved by adding natural edible and antimicrobial antioxidants with biodegradable chemicals. Nanotechnology techniques can improve mechanical properties and introduce intelligent function.
Packaging is revolutionized due to the integration of nanocomposites, nanosensors, biodegradables, nanocomposites for leakage-proof, gases-free, and pathogen-less food packaging. Modified nanoclays are one of the most reported nanoparticles for improvements in various materials properties. Because of their high water absorption and sealing capacity, they are well dispersed in diverse polymeric matrices and are influencing properties essential for food packaging materials.
Nanomaterials used in food packaging are typical metal-based nanomaterials, carbon-based nanomaterials, and nanocomposites.
Actually, nanotechnology-based food packaging can be divided in two types, that is to say, improved packaging and active packaging.
Nanotechnology and nanomaterials, it provides the opportunity for a new lightweight material with improved properties that protect food quality during transport, prolong the freshness of fruits and vegetables during store and preserved meat. To the foodborne islands caused by fungi, viruses, and bacterial agents that have caused considerable food safety concerns around the world. New food packing has emerged which is one of the most effective approaches to reducing foodborne islands. They are nanotechnology, which is the use and manipulation of structures with a dimension scale of nanometric range. The use of nanomaterials in food packing can reduce the growth of various microorganisms. Nanomaterial consists of nanoparticles made of semiconductor metal oxide, or any other particle that has high physicochemical and electromagnetic properties. The most widely used nanomaterial in a commercial product is silver, followed by carbon-based materials and metal oxides. The packing of agricultural products using nanomaterial has the following notable potential benefits: improved performance packing with hydromechanic and barrier characteristics, packing with nanoparticles embedded in antimicrobial packing such as silver nanoparticles, smart technology packing that could prevent or respond to crop deterioration. For example, applying polymer films that give different colors at different stages of product deterioration, dirt repellent and waterproof packing. Some of the nanomaterial used are nanoclay. The benefits of clay nanocomposite to be used as a packing material are improved shelf life, lightweight, heat resistant, and shade proof. However, the minor drawbacks of integrate nanoclays into polymers are the observation of reduced transparency. Nanomaterials commonly used for the detection of foodborne pathogens and toxins include gold nanoparticles, gold nanobursts, magnetic nanoparticles, quantum dots, silver nanoparticles, and silk nanoparticles.
Nanomaterials are categorized into four categories that are carbon-based, inorganic-based, organic-based, and composite multi-phase structures. Nanotechnology is a new science that provides us the opportunity of new lightweight material with improved properties by using nanomaterials. Some applications in food packaging are the use of nanoclays, silver nanoparticles, cellulose nanofibers. There are some nanomaterials used for antimicrobial purposes such as silver nanoparticles, cellulose nanocrystals, zinc oxide, and titanium oxide nanoparticles. There is no regulation for nanomaterials, but in the USA, the US FDA has recognized to carbon black, aluminum, nanoclays, and other nanomaterials as generally recognized as safe, and some countries have guidance for the use of nanomaterials in food packaging.
Nanotechnology offers substantial prospects for development of innovative products and applications in several industrial. Inorganic materials include metal oxide, salt, food carbon-based materials, sugar and carbon nanotubes, carbon black and clear. Nanoencapsulate consists of an organic shell and a core container. The bioactive ingredient nanocomposite is made to incorporate nanoparticles into a solid matrix in order to establish the excitant property. Son algunos nanomaterials and can provide antimicrobial properties to food packaging. Nanoparticles used in food packaging consist mostly of clay or silver. Clay is used to manufacture impermeable layer in packaging material, especially for plastic bottles, to offer mechanical strength or from a barrier against gases, volatile component, or moisture. Nanoclay in general recognized as an special fly for bio-based polymer reinforcement, as these can enhance barrier properties, frame, grain resin, and provide mechanical strength of biopolymer with very low clay content with biodegradability remaining intact. More recently, nanotechnology has shown promise and exciting potential to overcome the drawbacks of fly materials. Nanoparticles with flyer properties, such as maturing light, lapoint, and cyber nanoparticles are generally used to fly reinforcement.
In the case of the polyethylene terephthalate with nanoparticles of molybdenate, titanium oxide, silica, it's found that all nanocomposites show better thermal and mechanical properties in comparison with the neat bed. Antimicrobial nanomaterials presents are part of active packaging concept designed to carry the active nanoparticles that can be integrated into a food package. These antimicrobial systems are particularly effective because of the high surface-to-volume ratio and enhanced surface activity of the nano-sized antimicrobial agents, making them able to inactive microorganisms more effectively than their micro or macro-scale features.
Nanotechnology is used for different industrial sectors, one of them the food industry. In the packaging area, nanomaterials compete with the beds of macro-scale packaging, creating mechanical properties, gas barrier, thermal conductivity, and inertia chemistry, as well as psychochemical properties.